To be looking at graphing x squared, y equals x squared. So let's say we're graphing that and we're just going to look at the domain and range. This should be pretty easy for us. We know that when I plug in some values here, I can plug in some positive and some negative here. Sorry, my handwriting is a little messy with this. So plug in x, and we get 1 squared is 1, 2 squared is 4, and we get the same for the negatives, because when you square a negative and a positive, you still get a positive. So we have 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and you can keep going if you want. 3, 9, here's 9, 3, 9, and negative 3, 9. Alright, so we'll graph that in here. And again, still getting used to this tablet, so it's a little messy here. But my handwriting is always messy. Okay, so that's x squared, and then we can look at finding the domain. Is looking at our x values. You can plug in any x value, so you'd write this as x, such that x is all reals, and that is a set for that. And your range here, which is your y values, that is only positive values, so y is greater than or equal to 0. Okay, so if we look at this and we wanted to find the inverse, we know when we find inverses from yesterday's section, we're going to be looking at taking this, which is y equals x squared, switching x and y, so I'll get x equals y squared, and solving for y. So we'll take the square root of both sides here, and we get y inverse, or f of x inverse, equals, when you take a square root, you have plus and minus the square root of x. So that's why we're using this the square root here, like that. So since we already know points here, we also know points over here. So again, we're going to have x and y, and I'm just going to switch my chart here. So I'll have 4, 1, 0, 1, 4. I just am switching these, and then I have negative 2, negative 1, 0, 1, and 2. I just switched the x and y from over there. So graphing this, I have 0, 0, 1, 1, 1, negative 1, 4, 2, 4, negative 2, and then you could put the 9s on as well if you would like. Alright, again, it's a little messy, but my handwriting is always pretty messy. And then we know that for the domain range, we switch the domain and range. So now if we look at the domain here, which is your x values, that's going to be whatever you got for the range here. So your domain is whatever you got for the range over there. So your domain is going to be x is greater than or equal to 0. And your range is all reals, because it's whatever you got for the domain over here. Okay, moving on. Now we are looking at, we're going to skip that. So now we're putting a restriction on the domain. So here's the domain now. It's already telling you what to plug in. So that's the domain. So now instead of plugging in positive and negative values, you're only plugging in positive. So we can plug in 0, we get 0. Plug in 1, you get 1. Plug in 2, you get 4. Plug in 3, you get 9. So now it's not going to be that entire parabola, it's just going to be half of it, only the positive values. 1, 1, 2, 4, 3, 9. Right here. Okay, and then we can graph that in here. Beautiful graph. And so we know that the domain is, it already told us what it was, so that's just going to be x is greater than or equal to 0. And then your range here, if you look at your y's, that is going to be still positive values. So y is greater than or equal to 0 here. So again, for this one, you only have the positive. It doesn't say plus and minus. So that's why we're only going to be using the positive part here. So we have 0, 0. We have 1, 1. If you want to rewrite your chart here and then just switch them, your x values and your y values will be switched. So now I'm going to put 0, 1, 4, 9 for my x, because that was the y here. And I'm going to put 0, 1, 2, and 3 for my y's. So 1, 1, 4, 2, and 9, 3. 9, 3. Okay, so putting this all in here. And then we can say the domain and the range of this. So your domain is x is greater than or equal to 0. And your range is y is greater than or equal to 0. And that's when we put a restriction on our domain. Moving on, we're looking at finding the translations of the graph. So this is going to be our parent graph, the square root of x, which we just graphed in the previous slide. So we're going to start by just using the parent graph. So we have y equals the square root of x as our parent graph. We already know some points here. 0, 0. If you want to rewrite them, 0, 0, 1, 1, 4, 2, 9, 3, and so on. So 0, 0, 1, 1. And it's important to put this in because then it'll just be a translation after we have the parent graph. It's 4, 6, 8. Here's 9, 3. And you can write the points in as well so that when you actually do your translation, then it'll be easy to just move the points and add or subtract, whatever you're doing. Alright, sorry about the messy graph there. It's hard to do the graphs with the tablet. Anyways, we know the domain and the range here, so I'll just write that out. The domain, x is greater than or equal to 0. Your range, y is greater than or equal to 0. Okay, so now we are going to look at, oops, I don't know what I just did there. Oh, we can change the color. Okay, so we're going to change the color. So we're going to look at this one first. So notice how this plus 2, oh, it didn't change the color, it's still red. Okay, so this plus 2 is going to be moving 2 units up. So if it's outside the radical, or if it's not part of the radicand, then you're moving in a vertical direction. So you go up 2. So you go 1, 2. So now 0, 0 is now 0, 2. Because this tells us go 2 units up for all of your points. 1, 1 now becomes 1, 3. Because I'm just going 2 units up. So I'm adding 2 to all of my y values. 4, 4, and 9, 5. Oh, that's a beautiful 5 there. Okay. So then we graph that. And also not that accurate. That's okay. Alright, so we're finding the domain and the range here. The domain is now going to be x such that x is now greater than or equal to 2, and range such that your range is stayed the same because, oh, sorry about that, actually we need to redo that. Oh, I don't know what's going on here. Let's see. Okay, redo that. Okay, so the domain we didn't move left or right, so your domain is just still x is greater than or equal to 0, and the range we moved up 2, so your y is now greater than or equal to 2. Sorry about the mess up before. There we go. Okay, moving on to when it's minus 1. Let's see if we can change the color here. I don't know if we can do that or not, but let's try that. Let's try for blue. Okay. Nope, still didn't change that. Okay, we'll try again. Okay, so, nope, now that's red. That's okay. Anyways, we're going down 1. So we're going to move our graph down 1. So now we're at 0, -1. And 1, 1 now becomes 1, 0. Moving all your points for this one down 1. Okay, this one here, 4, 2 now becomes 4, 1, and so on. So we'll graph that in with this beautiful graph. All right, so for this one here, we have a domain. Let's get rid of this here. Domain that is going to be, that did not change, so x, such that x is still greater than or equal to 0, and your range now, since we went down 1, now your y is greater than or equal to -1. There we go. Moving on. Okay, so now we have the square root of x plus 3. This is a horizontal translation, and notice when it's underneath the radical, it's going to be doing the opposite of whatever your radical says. So this one here is going to be going 3 units left because it's the opposite of what it's doing. So if you wanted to draw in your parent graph, that would be easier. If not, we could just go straight from starting at, we usually start at 0, 0, so if I go left 3, I'm going to be at -3, 0. Then we had a point of 1, 1. I'm going to go left 3, so then I'll be at -2, 1. We had the point of 4, 2. So then if I take 4, 2 and I go left 3, I'll be at 1, 2, and so on. Draw this graph in. That one's a little bit better. So now we're looking at the domain and the range. So now our domain changed because we moved to the left. So for our domain, now we went to the left 3, so now we have x is greater than or equal to a -3. Our range, that did not change. So now our range is just y is greater than or equal to 0. Okay, so now we're going to be looking at this -2 here. So the -2 is telling us to go 2 units to the right because we're looking at, has to go the opposite way. So we go 2 units right, so now we're starting here, which is a point 2, 0. Okay, if we had the point 1, 1, we're now translating it 2 units over. So that will be the point 3, 1. Before we had the point 4, 2, we're going to the right 2 units. So now we should be at 6, 2, and so on. We'll draw this in here. I think my graphs are getting a little bit better. We now have the domain is x, such that x is greater than or equal to 2, and the range is y, such that y is greater than or equal to 0. So again, this just changed the domain. Okay, this is looking at a vertical stretch or compression, and we've already done these with absolute values and also with quadratics. So you do the same thing. If your A is going to be between 0 and 1, then it's going to be a vertical shrink. And that's because that's going to make your y values be smaller. And if your A, meaning the number in front of the square root, is greater than 1, it's going to be a vertical stretch. So we can try some of these. If we do this one here, it's not going to change the domain and the range. So let's try and plug in some points here, 0, 1. Remember, we're plugging in perfect squares because it's underneath the square root. 4, 9, and so on. So plug in 0. 0 times 2 is 0 still. Plug in 1. 1 times 2 is 2. Plug in 4. Square root of 4 is 2 times 2 is 4. Square root of 9 is 3 times 2 is 6. So we can plot those. 0, 0, 1, 2, 4, 4, and 9, 6. All right, so that is our vertical stretch. And if we go ahead and do this one here, it'll be a vertical shrink. Putting some of these together. So for this one here, we're going to first start off by graphing -2 square root of x. And this is going to be used as our parent graph. So notice here, if there's a negative in front, then this is going to be below the x-axis. So then for this, your domain, you're still plugging in the same x values, so your x is still greater than or equal to 0. But now your range is going to be now less than or equal to 0 because it's below your x. And let's see what happens when I actually plug in values. So we're plugging in 0, 1, 4, 9, so on. So we go 0 times 0, or times -2 is still 0. Square root of 1 is 1 times -2 is a -2. Square root of 4 is 2 times -2 is a -4. Square root of 9 is 3 times -2 is -6. So we can go ahead and graph that. But what happens is now it's going to be below. So we have 1, -2. We have 4. 1, 2, 3, 4. -4 down here. We have 9, -6 down here. Okay, so this is our parent graph. And then we're going to put our translations together. Look at that. That's looking pretty good. And we can verify our domain and our range here. Your domain, x is greater than or equal to 0. And your range is y is less than or equal to 0. It's below your x-axis. So now let's look at our translations here. If it's x plus 1 underneath the radical, then this is going to say we're going to go 1 unit left. Remember, when it's underneath the radical, you do the opposite of the sign. And this means we're going to go 3 units down. So what you're going to do, if you're going 1 unit left, you're going to subtract 1 from all of your x values. If you're going 3 units down, you're going to subtract 3 from all of your y values. So you can go ahead and make a new chart here by doing that. 0 minus 1 is a -1. 1 minus 1 is 0. Sorry, this is kind of on an angle here. 3 and 8. And then we're going to subtract 3 here, so we get a -3. -5. -4 minus 3 is a -7. And then we have -6 minus 3 is a -9. Or you can just count the boxes on your actual graph. Okay, so let's do that. -1, -3. 1, 2, 3 here. Here's our first point, -1, -3. And that's an important point because that's also going to give you your domain and range. You have 0, -5. 0, -5. 3, -7. 3, -7 down here. And 8, -9. Okay, so we're going to graph that in. And here's the translation. So now for this one, you can just look at your graph and you can see that the domain, look at your x values. The smallest one is a -1. So x is greater than or equal to -1. Or you could have just taken the radicand and said that has to be greater than or equal to 0 and solved for x. And your range is going to be it's below -3, so y is less than or equal to -3. Whoops, that's a -3 there. All right, so hopefully you can read that. And that is the end of 7.8.